Section 7.4b. Row echelon form of a matrix, also called Gaussian elimination. Row echelon form is abbreviated REF. That's the abbreviation that you are going to see on your calculator when we get into using the calculator, not this section, but in the next one. Rules to be in row echelon form. Any row containing all zeros must be at the bottom of the matrix. The first non-zero entry in any row not containing all zeros has to be 1. So as we go row by row, the first non-zero entry in the row has to be a 1. The last thing to be in row echelon form, for 2 successive rows, the leading one in the higher row is farther to the left than in the lower row. That's row echelon form. Reduced row echelon form. On your calculator, you will see that as RREF, called Gauss-Jordan elimination. First of all, it has to be in row echelon form to be in reduced row echelon form. If it's already in row echelon form, then every column that has a leading 1 has zeros in every position above or below the 1. Some examples of row echelon form and reduced row echelon form that you will want to take a look at are on page 515 in your book. Look at example 5. Those 3 examples, parts A, B, and or A through F actually, in the book give you a good idea of what row echelon form is compared to reduced row echelon form. Steps in getting to reduced row echelon form. Step 1. We want to get a 1 in row 1, column 1. To do that, we will always multiply by the reciprocal if it's not always already a 1. So that first step will always be the same. Get zeros in the rest of that column. And this is where, if you think back to what we did with elimination, remember, each row in the matrix is an equation. So we want to get zeros in the rest of that column essentially says that we are eliminating x's in all of the other equations. Then we want to get a 1 in row 2, column 2. Again, you're going to do that by multiplying by the reciprocal. After you do that, you're going to want to get zeros in the rest of that column. Same thing as you're doing using elimination. Okay, and you're going to do these same steps over and over and over and over again until you get 1s in row 1, column 1, zeros in the rest of the column, a 1 in row 2, column 2, zeros in the rest of the column, a 1 in row 3, column 3, zeros in the rest of the column, and so on, depending on how many variables you have. Now, the key to this is you have to go in this order. Okay, so you must do row 1, column 1, and all of column 1 before you worry about row 2, column 2, and so on. You have to go in this order. Once you get a 1 in row 1, column 1, and you go to get zeros in the rest of the column, use the 1 from row 1, column 1. Here, when you get a 1 in row 2, column 2, and then you want to get zeros in the rest of the column, use the 1 from row 2, column 2. So in other words, the 1 that you create in that column, you're going to want to use that and multiply it and add it to the rows to get zeros in the rest of the column. And you'll see that when we go through an example here. Okay, so we're going to solve this system now using Gauss-Jordan elimination, meaning that we want to get it to reduced row echelon form following the steps that we just saw on the previous slide. So the first thing I'm going to do is we need to write an augmented matrix here. First row is our first equation. So 1, -2, 3, and 9. Second row, -1, 3, 0, -4, and 2, -5, 5, and 17. First step, get a 1 in row 1, column 1. That has already been done. So I go to step 2. I need to get zeros in the rest of this column, which is essentially taking this first equation and saying I want to use this first equation and eliminate x's in everything below. So I'm going to leave the first row alone. 1, -2, 3, and 9. I want to eliminate x's by using this one that we just created, or our first equation right here, and eliminate x's in the second one. How do I do that? Well, just simply add them together. So I'm going to take row 1 and add to it row 2. When we do that, we get 0, 1, 3, and 5. Now I want to use this top equation again, but now I want to get rid of the x's in the bottom equation. What do I need to multiply this top equation by so that when I add it here, I get a 0? -2. So I'm going to take -2 times row 1, which is equation 1, and add it to row 3. When we do that, we get 0. We get 4 minus 5, which is -1. -6 plus 5, which is -1. -18 plus 17, which is -1. So we're done with column 1. We have a 1 in row 1, column 1, zeros in the rest of the column. Next step. Get a 1 in row 2, column 2. That's already been done. So now we need to get zeros in the rest of that column. So looking at this matrix, what can I multiply this 1 by so that when I add it to the top, I get 0? I need to multiply it by 2. So I'm going to leave row 2 the same. 0, 1, 3, and 5. I need to get a 0 in the rest of the column. So I want to get a 0 up above this 1 by taking 2 times row 2 and adding it to row 1. We get 0 plus 1 is 1. 2 minus 2 is 0. 6 plus 3 is 9. And 10 plus 9 is 19. Now I want to use this 1 right here and get a 0 down below in the column. What do I need to do? Well, all I need to do there is take row 2 and add it to row 3. We get 0. 1 minus 1 is 0. 3 minus 1 is 2. 5 minus 1 is 4. There, column 2 is done. I'm going to come up here. Next, we need to get a 1 in row 3, column 3. To get a 1 right here, we always multiply by a reciprocal anytime that's not a 1. So I want to take 1/2 times row 3. When I do that, I get 0, 0, 1, and 2. And that's the only change I'm going to make. So my first equation, 1, 0, 9, 19 stays the same. Second one, 0, 1, 3, 5 stay the same. Now I have a 1 in row 3, column 3. I need to get zeros in the rest of that column. So I'm leaving row 3 alone. 0, 0, 1, 2. Need to get 0 right here. What do I need to multiply this 1 by so that when I add it there I get 0? -9 times row 3 and add it to row 1. When we do that, we get 1, 0, 0, and 18. -18 plus 19 is 1. What do I need to multiply this 1 by to get a 0 right here? -3 times row 3 and add it to row 2. When we do that, we get 0, 1, 0, -6 plus 5 is -1. Now here is what you have done by using Gauss-Jordan elimination here. Remember, each row represents an equation. So now this top row represents what equation? X, 0y, 0z, x equals 1. What does the second row represent? Y equals -1. What does the third row represent? Z equals 2. So our solution to this system is the order triple 1, -1, 2. System of 4 equations, 4 unknowns. Think about what we would have to do here if we were going to solve this, what we did the first half of the chapter. We never did 4 equations, 4 unknowns, okay? But if we did, we would have to first pick a variable to eliminate to get it to 3 equations, 3 unknowns. Okay, so since our second equation here is missing the w, we would probably combine the first and third equation, eliminate w, first and fourth equation, eliminate w, then we have it down to 3 equations, 3 unknowns. Then we would need to either pick x, y, or z and do the same thing. Let's eliminate x's from that system of 3 equations, 3 unknowns. Eliminate x's twice to get to 2 equations, 2 unknowns. Solve that system, plug everything back in to get to your solution. So understand that that would be a lengthy process. What we're going to do here is going to be a very lengthy process. We're just doing it to show you that it's the same 2 steps every single time. Get a 1 in row 1, column 1, get zeros in the rest of the column. 1 in row 2, column 2, zeros in the rest of the column, and it's doing the same pattern over and over and over again. So the first thing I'm going to do here is I'm going to write our augmented matrix. As I do that, remember we know we want a 1 in row 1, column 1. So that means we want x to be a 1. So all I'm going to do right away here, so I don't have to write this twice, is I'm going to switch row 1 and row 2. In other words, I'm going to switch the order that those 2 equations are written in. So my top one now is going to be 1, 2, -1, 0, equal sign to 2. So I've switched row 1 and row 2. So now my top equation becomes my next one, 0, 1, 1, -2, and -3. 2, 4, 1, -3. And 1, -4, -7, -1, and -19. We have a 1 in row 1, column 1. We need zeros in the rest of that column. So that's going to be our next step here. Okay, as we look at this, we can see our top 2 rows don't need to change. I have a 1 here. I have a 0 here. So that's going to stay the same. So 1, 2, -1, 0, and 2. 0, 1, 1, -2, and -3. Use the one that you have created up here. What do I multiply that by so that when I add it here, I get 0, -2 times row 1 and add it to row 3. When we do that, -2 plus 2, 0. -4 plus 4, 0. 2 plus 1 is 3. 0 minus 3 is -3. And -4 minus 2 is -6. Use that 1 to get a 0 right here. What do I need to multiply by? -1. So I'm going to take -1 times row 1 and add it to row 4. When we do that, we get 0, -6, -6, -1, and -21. Column 1 is done. Same step. Run now in row 2, column 2. Good thing, that's already been done. Zeros in the rest of the column. So what 2 rows now are going to end up unchanged? Well, I have a 1 in row 2, column 2, so that row is going to end up unchanged. And I have a 0 in row 3, column 2, so that row is going to be unchanged. So let's recopy those. 0, 1, 1, -2, -3, 0, 0, 3, -3, -6. use this 1 to get a 1 up here. What do I need to multiply that 1 by? -2. So I'm going to take -2 times row 2 and add it to row 1. When we do that, we are going to get 1, 0, -3, 4, and 8. Need to get a 0 down here. What do I multiply this 1 by to get a 0 here? 6. So I'm going to take 6 times row 2, add it to row 4. When we do that, we get 0, 0, 0, -13, -39. Next, we need a 1 in row 3, column 3. To get a 1 there, it's not a 1. We always multiply by the reciprocal. So I need to take 1/3 times row 3, and that's all that we are going to change. So I'm going to leave row 1 alone. 1, 0, -3, 4, and 8. Row 2 stays the same, 0, 1, 1, -2, and -3. I'm now going to take 1/3 times row 3. We get 0, 0, 1, -1, -2. Row 4 stays the same, 0, 0, 0, -13, -39. All right, now we want zeros in the rest of column 3. So these two bottom rows do not need to change. So let's rewrite those. 0, 0, 0, -13, -39, and 0, 0, 1, -1, -2. I need to get a 0 up here. What do I multiply this 1 by? So that when I add it there, I get 0. 3 times row 3 plus row 1. When we do that, we get 1, 0, 0, 1, and 2. You got to get a 0 right here. What do I multiply this 1 by to get a 0 up here? -1 times row 3. Add it to row 2. We get 0, 1, 0, -1, -1. We're on our last column finally. I'm going to come up here. Need a 1 in row 4, column 4. Multiply by the reciprocal. So our top 3 rows are not going to change. 1, 0, 0, 1, and 2. Row 2 is not going to change. 0, 1, 0, -1, -1, and 0, 0, 1, -1, -2. I'm taking 1/13 times row 4. Actually, -1/13. We get 0, 0, 0, 1, and 3. Finally, zeros in the rest of that column. So our bottom row is not going to change. Let's start with the row right above it. To get a 0 there, I'm going to just add those 2 rows together. So I'm going to take row 4 plus row 3. We get 0, 0, 1, 0, 1. I'm going to do the same thing here. I'm going to add row 4 to row 2. We get 0, 1, 0, 0, 2. And finally, get a 0 up here. I'm going to take -1 times row 4 and add it to row 1. We're done. There's reduced row echelon form. Remember, each row represents an equation. X equals -1, Y equals 2, Z equals 1, W equals 3. So we have the ordered set: -1, 2, 1, and 3.